Hello students, I am Dr. Ritu Agarwal from ABES Engineering College. Today I would be discussing the important questions or the frequently asked questions of Unit 2. So let us discuss the important questions of Unit 2 which are being asked in the examination. So these are some of the important questions which are frequently asked in the examination. So the very first question is, what is the difference between multiplexer and encoder? As we have already discussed in the previous lectures, that multiplexer is a combinational circuit in which we have n number of selection lines, 2 to the power n number of inputs and one output. And in case of encoder, we do not have any selection line. So the basic difference between the multiplexer and encoder is that here we have to select one of the inputs in case of multiplexer, while in case of encoder, we would be encoding the digits. Rest, all the details have already been discussed. So whenever you have to write the difference of these two, we will write in a tabular form. First of all, we will write what is a multiplexer, what is an encoder. Then we will see what exactly the differences are there. So 2 to 3 differences we have to write while writing the answer of this question. Then second question comes out to be, what is a magnitude comparator? Now, what is a magnitude comparator? Again, it is a combination circuit in which the two numbers are being compared, and at the output we will see whether the two numbers, if the two numbers are A and B, whether the two numbers are greater than B, A is greater than B, or A is less than B, or A is equal to B. So first of all, we will write or we will define what is a magnitude comparator, and then you have to design a single bit comparator circuit using logic gates. Now, how you will design a single bit comparator circuit? So for that, designing it, you will have to write the truth table in which the two numbers have to be taken with one bit each or single bit each. Then at the output side, we will be having three outputs, A greater than B. Then we have A less than B. And then we have A equal to. So these will be the three outputs, and A and B will be the inputs. So in this case, after writing the truth table, like if I have 0, 0, then this will become 0. This will also be 0, and A equal to B will become 1. So in this manner, we can have 4 combinations of A and B, and then 4 combinations of outputs also. Now, based on this truth table, we will draw the K-maps. So how many K-maps will be required? We require 3 K-maps as we are having 3 outputs. And how many variable K-map? 2 variable K-map will be there. And with the help of K-maps, we will find out the logic equations. And those logic equations, with the help of those logic equations, we can draw the logic diagram using different logic gates. So this all we will have to write while writing the answer of this question number 2. Then we come to question number 3, which is considered to be a very important question, that you have to implement the function of ABCD is equal to summation 0, 1, 3, 5, 7, 10, 11, 13, 14, 15 using 8:1 multiplexer. Now, if I have to draw or if I have to implement this multiplexer, I will require some selection lines. So if I have 8:1 multiplexer, it means how many selection lines are required? 2 to the power 3:1, it means 3 selection lines would be there. 8 number of inputs are there and 1 output is there. Now the question is that how to implement it. So it has to be implemented with the help of some implementation table. So we can draw the implementation in this manner. Since we are having A bar 0, 1, 2, 3. So how many data inputs are there? From D0 to D7. We have 7 inputs. Then for A bar, we have 0 to 7. It means that in case of truth table, we see that if I have A, B, C, and D, so I can write it as 0, 0, 0, then 0, 0, 0, 1, then 0, 0, 1, 0. So we can observe that the value of A remains 0 from 0 to 7, and from 8 to 15, the value of A remains 1. So here we have written for A bar 0, 1, 2, 3, 4, 5, 6, and 7. And for A, when A is equal to 1, those are the cases for 8, 9, 10, 11, 12, 13, 14, and 15. Now we will circle those numbers, only those numbers which numbers are being given in the question. So these numbers are 0, 1, 3, 5. So first of all, we have encircled 0, 1, 3, 5. First number is 0, then 1, then 3, 5, 7, 10, 11, 13, 14, and 15. These numbers are being encircled. And on the basis of this, if the circled number is on the top, then we will write A bar corresponding to this. Like in the second column, again, 1 is circled and 9 is not circled. It means again we will write A bar. Then in the third case, we have A is equal to 10 is circled. So we will write A. Then if both the inputs are circled, means 3 and 11, both are circled, then 1 is written. If no number is circled, then 0 will be written. Again, both the numbers are circled. So 1 is written. Again, the lower one is circled. So A is written. And both the numbers are circled. So 1 is written over here. So this is the implementation table. And on the basis of this implementation table, we will draw the 8:1 multiplexer. So the selection lines will be B, C, and D. And the input lines will be based on the implementation table. Means D0 is connected to A bar. So here we have drawn it with the help of A bar. So here we are having a NOT gate, or here we can say this is the NOT gate, which is giving the output as A bar. So D0 is connected to A bar. D1 is again connected to A bar. Then D2 is directly connected to A. Then D3 is connected to logic 1. D4 is connected to logic 0. D5 is connected to logic 1. Then D6 is connected to A, and D7 is again connected to logic 1. So this is the designing or the implementation of the function using 8:1 multiplexer. Then we come to another question, that is implement a 4:1 multiplexer using 2:1 multiplexer. So to implement this 2:1 multiplex, 2:1 multiplexer. So we have two inputs and one selection line. Another 2:1 multiplexer, again, two inputs and one selection line. And these two will further be connected to another 2:1 multiplexer with two inputs and one selection line. And in this manner, we can draw 4:1 multiplexer. So here we have 1, 2, 3, and 4 inputs with one selection line over here and one selection line over here. So since in 4:1 multiplexer, we have 4 inputs, 2 selection lines, and 1 output. So this would be the manner in which we can draw the 2:1 multiplexer. Then we have fifth question, that is explain BCD adder with proper block diagram and truth table. So again, first of all, you will have to define what is a BCD adder. Then you have to draw the truth table. On the basis of the truth table, we can find the expression for BCD adder, and we will draw the block diagram as we have already discussed in the previous lectures. Then the sixth one is a design of full adder using half adder. Also give truth table of full adder along with K-map. So again, you have to design a full adder. So first of all, you will have to write what is a full adder, then the truth table of the full adder. Along with it, you will have to write the K-maps, and then with the help of these logic equations, you will draw the full adder using half adder. Seventh question is design the logic circuit of 4-bit comparator explained by giving truth table. So this also we have covered in the previous lectures. Then the eighth one is draw and explain priority encoder. So in this case, first of all, you will have to discuss what is an encoder, why priority encoder is used, what is the use of priority encoder. Then after this, you will again have to draw the truth table, and on the basis of truth table, you will have to draw the K-maps, in which you will have to see that how the priority works. Either it is working for the highest priority or it is working for the lowest priority. And then you will draw the logic circuit. Then the ninth question is explain full subtractor, which is quite simple. And the last one, that is the 10th question, is design a 3:8 decoder circuit using gates. So this also we have already discussed, that what is a decoder circuit and how we can design a 3:8 decoder. So these are some of the important questions which can come in your examination from Unit 2. These are the references. Thank you.